Good morning. Today's topic is molecular mechanism of muscle contraction. So as we have discussed earlier, the muscle contraction will be coordinated or will be regulated with the help of the action of motor nerve. So one motor nerve or the unit of nerve, that is a neuron. So one motor neuron will be there, and it will make a connection with the muscle fibers. So this one is a single muscle fiber. So from the name, this single muscle fiber is known as, or the connection in between this motor neuron, this one is the motor neuron, and the muscle fiber is known as the neuromuscular junction. The neuromuscular junction, and these neuromuscular junctions are everywhere in between the junction of this motor neuron and the muscle fiber, and each area of neuromuscular junction will be known as the motor end plate. So what is motor end plate? The motor end plate is the specific area where the NMJ will be produced or the neuromuscular junction will be produced, right? So if you will try to focus this structure of NMJ, then the structure must be involved with the axonal terminal and the muscle fibers membrane. So this one is the membrane of muscle fiber. Right? So this membrane of the muscle fiber, in one word we know this membrane of muscle fiber as the sarcolemma. So basically the connection or the junction will be happen in between the neuronal terminal or the motor nerve ending or the motor neuronal ending with the sarcolemma, right? So again, if we will try to focus on the structure of this sarcolemma, so on that moment the sarcolemma is having this type of structure, this type of continuous structure, and these are the projection or protrusion of the muscle fiber of that muscle membrane or the sarcolemma, right, of the sarcolemma, and this one is known as a T-tube. So what is T-tubule? This T-tubule is nothing but a protrusion of the sarcolemma. This one is the sarcolemma. So this sarcolemma is having the protrusion towards the inner word and it will produce the T-tubule. So we can say that this T-tubule is nothing but a sarcolemma, right? So it is an extension of the sarcolemma. So that one is the first thing. Second thing is, though according to our previous discussion, that one motor neuron is having its connection here. So this one is the motor neuron. Right? So that this area is the neuromuscular or this area is known as the motor end plate. Right? So within this motor end plate region, what will be happen? Synaptic transmission will be happen. So synaptic transmission will be happen from the motor neuron to the synaptic cleft area and then ultimately to the sarcolemma, right? So according to our previous discussion of the synaptic transmission, we know that depending on the two different types of synaptic transmitters, the two different types of motor end plate potential will be produced. So we have the two different types of neurotransmitter. First one is the excitatory type of neurotransmitter, and second one is inhibitory type of neurotransmitter. So in the first case, some example or of one famous example, that is the acetylcholine, and for the second one, the famous example is the GABA, right? And several examples are there, but these two are the main famous examples of this excitatory or the inhibitory type of neurotransmitters, right? So when from the from that axonal terminal, if the inhibitory type of neurotransmitter will be released, on that moment it will act on the postsynaptic membrane or postsynaptic area. That means here the postsynaptic area is, that is the sarcolemma. So when this inhibitory type of neurotransmitter will be released from the presynaptic area, that means from the motor neuronal area, and it will act on the postsynaptic membrane, that means on the sarcolemma. So on that moment, the opening of the potassium or the chloride ion channel will take place, which ultimately cause the hyperpolarization of that particular area, which denotes that no further activation or no further electrical activity will take place to excite that muscle membrane or to excite that sarcolemma. So this sarcolemma area will be inhibited or will be inhibited, right? That one is the first example. On the second case, this second case is very important for our molecular mechanism of muscle contraction. That is, in case of the second condition, that means when the excitatory type of neurotransmitters will be released from the neuronal terminal, or that means from the presynaptic area, and when they will act on the postsynaptic area. So what is the postsynaptic area here? The postsynaptic area is the sarcolemma. So on that moment, what will be happen? Now it will lead the activation of or the opening of sodium ion and the calcium ion channel or the calcium ion channel. That means sodium or calcium ion channel opening. So it leads to the depolarization. Right? So as we know that depolarization means the activation or the excitation of that particular area. From our previous discussion, we can say that depolarization means the initiation of one new action potential will take place. So here the depolarization will take place on the sarcolemma region, right? So this depolarization leads to the formation of one new action potential on the sarcolemma region, and as this depolarization or the action potential is propagatory in nature, and though this T-tubule is a extension of the sarcolemma, so that we can say that this action potential will travel through that sarcolemma structure. That means we can say that when this action potential is traveling through that sarcolemma structure, so it is always traveling through the T-tubule structure, right? So this one was the first instant. On the second instant, the structural instances or the structural integrals. So at first, this T-tubule is having one specific type of protein. One specific type of protein on the surface of the T-tubule, the both sides, right? on the both sides. These proteins, those proteins are known as DHPR or dihydropyridine receptor protein. The function of those proteins are only one. So what I said, that is from the previous one, that is the neurotransmission was taking place in between this motor in-plate region, and when the excitatory type of neurotransmitter will be released from the presynaptic area to the synaptic cleft, and ultimately it will work on the postsynaptic area. Here the postsynaptic area is, that is the sarcolemma. So on that moment the activation of the sodium or the calcium ion channel will take place, so that the depolarization will take place. It means that the origin of one new action potential, right? And though the action potential is propagatory in nature, so this action potential will travel from their origin. Clear up to this part? Next one is, that is the structural integrity of the sarcolemma. So according to the structural integrity, the sarcolemma is having one extension. That extension is known as the T-tubule, and along this T-tubule structure, the T-tubule is having one specific protein on its surface. The protein is known as the DHPR protein or the dihydropyridine receptor protein, and these proteins are having only one function. That means when this action potential will travel along with this T-tubule structure, they can, or those proteins can sense the voltage changes. That means they can sense that action potential has arrived on that particular area, so that they will get activated. They means the DHPR. So what is the story now? The story is, when the action potential will be originated on that particular area, and they will start the traveling. So on that moment, when they are traveling through the T-tubule region, so on that moment the presence of the DHPR or the dihydropyridine receptor protein is there on the surface of the T-tubule. So the T-tubule can sense the arriving of the action potential, so that the DHPR will be activated. Up to this part story is clear? Fine. So next one. Next one is another one, structural integrity, that is known as, that is known as the cistern. That is known as the cistern. So these two different parts are known as the terminal cisternae, and whereas this area is known as the longitudinal tubule. And these two are the unit of a common thing or a common structure, that is known as the sarcotubular system. Right? So these are the sarcotubular system, and these sarcotubular systems are present on the both sides of the T-tubule. See, so this one is the T-tubule, and on the both sides of the T-tubule is having the sarcotubular system, right? And this sarcotubular system is having mainly the two different structural integrity. First thing is known as, or the first structural integrity is known as, that is the terminal cisternae, and second one is known as the longitudinal tube, right? So what is the function of this terminal cisternae? Now the function of this terminal cisternae is only one again. So the function of terminal cisternae is, it will help to store the calcium ions. So it will help So the function of terminal cysterine that is helps to store the calcium ion, right? First thing. Second one is that is on the surface of this terminal cysterine there is one specific channel is there, or one specific protein is there. See, one specific protein is there on the surface of the terminal cysterine. One specific protein is there which is present just opposite to the DHPR, which is present on the surface of the T-tubule. So these are the DHPR. These are the DHPR. See, just opposite to the DHPR on the terminal cysterine, one specific membrane protein is present. The name of that specific protein is ryanodine receptor protein. Ryanodine receptor protein. So what is the function of this ryanodine receptor protein? These ryanodine receptor proteins are nothing but a calcium ion channel. So they are the calcium ion channel. Right? Up to this part clear? So sarcolemma, this sarcolemma is having the extension that is known as a T-tubule. On the both side of the T-tubule there is another one structural integrity which is known as the sarcotubular system, and this sarcotubular system will be formed with the help of the combination of this terminal cysterine and the longitudinal tubule. This terminal cysterine is having only one function. The function is that is it will store the calcium ions, right? And on the surface of the terminal cysterine there is another one specific membrane protein which is present on the just opposite side of the DHPR, is known as the ryanodine receptor protein. It is nothing but a calcium ion channel, right? Now the third one is that is the L-tubule or longitudinal tubule. This L-tubule is having one specific membrane protein again. One specific membrane protein again, and this protein is known as quite difficult. I'm writing here. So this surface protein of the longitudinal tubule is known as the sarca. What is the full form of this sarca? Sarcoplasmic, endoplasmic, reticulum, calcium, ATPase pump. Right? So the structure of this membrane protein is known as the sarca. What is the full form of this sarca? The sarca means that is the sarcoplasmic, endoplasmic, reticulum, calcium, ATPase pump. Right? Up to this part clear? Now, what is the function of this sarca? Now this sarca will help to gather or collect the calcium ion from the outside to the longitudinal tubule area, and then this calcium ion again will be stored to the terminal cysterine. So what is the main phenomenon? So though previously we came to know that this terminal cysterine will help to store the calcium ion, and when this calcium ion will be released from this terminal cysterine for their own function, and when the function will be completed with the help of the calcium ion, so they has to get back inside this terminal cysterine. So how they will get back? Now due to the action of this sarca, so that from the outside the sarca will help to collect the calcium ion, and again it will help to store this calcium ion in the terminal cysterine. We was discussing about the molecular mechanism of muscle contraction. So we have come to know from our previous class that the structural integrity of the sarcotubular system, right, as well as the structure of the sarcolemma and motor end plate, and what is the motor end plate potential, or what are the motor end plate potentials. So if the excitatory type of neurotransmitters will be released, then only the postsynaptic area will be activated, or they will be depolarized due to one specific potential. That potential will be known as the excitatory type of excitatory end-plate potential, or this potential will help to form or to origin the depolarization on the postsynaptic membrane, right? So when the depolarization will be happened, the action potential will be produced, and this action potential will be traveling through the sarcolemma structure, and though the structure of the sarcolemma is associated with the T-tubule also, because this T-tubule is nothing but an extension of the sarcolemma, so that the action potential will travel through the T-tubule again. So within this T-tubule, the specific type of one protein was there. The name of that protein is that is the DHPR, or dihydropyridine receptor protein. This one is the dihydropyridine receptor. And on the just opposite to this T-tubule, there was another one structure. The structure was, that is the structure of the sarcotubular system. So these sarcotubular systems are having the two different structural integrity. First one is known as the terminal cysteine, and this one is known as the L-tubule, or longitudinal tubule. So the function of the terminal cysteine was only one, that is it will help to store the calcium ion, and when the body will, or when in the muscular region the calcium will be required, so on that moment through one specific protein or surface protein which is present on the surface of the terminal cysteine, and also just opposite to the DHPR receptor, it will help to release the calcium ion from the terminal cysteine. The name of that protein was, that is the ryanodine receptor protein, right, and which was nothing but a calcium ion channel. Right, up to this part clear? So another one is, that is the longitudinal tubule. So on the longitudinal tubule there was another specific surface protein. The name of that protein was SERCA, S-E-R-C-A. That is the sarcoplasmic endoplasmic reticulum calcium ATPase pump. So it will help to get back the calcium ions from the outside to the longitudinal tubule area, and then these calcium ions will be stored in the terminal cysteine region. But now the question is, what is the mechanism, or why we are discussing about those things, or blah 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 blah. Actually, beneath this whole structure, the centrally another one structure is there, that is known as the myofibril structure. And these myofibril structures are only the contractile area of the muscle, of one muscle fiber. So contractile area means, so from our previous knowledges, that means from class 10 or class 11 or class 12, we know that some contractile proteins are there which will help to contract the muscles, and those proteins are mainly the actin. Next, myosin. Right? So, this actin and myosin are having, or these actins and the myosins are present on those contractile area in a specific arrangement. If we will highlight on that particular arrangement, so on that moment we can see that these are the actin fibers, and these are the myosin fibers. So these are the actin and those are the myosin. Right? So, what are the structural integrity? Now, actually, these myosins are having a specific structure: the globular myosin and the linear myosin, or we can say that myosin head and myosin tail. So, the tail parts will be associated in these areas, whereas the head areas are present on the area of the actin rich areas. So these are the myosin heads. These are the myosin heads. These are the myosin heads and these are the tail region. And this one is known as, or this area is known as the Z line. Again, another Z line. So from the Z line area, these actin filaments will start their traveling. So the distance between one Z line to another Z line will be known as the sarcomere. Will be known as the sarcomere, right? So if at any condition the shortening of the sarcomere will take place, that means the normal structure was this. If the shortening of sarcomere will take place, that means we can say that the muscle has been contracted. So how this muscle has been contracted, or how this the distance between the Z line has been shortened, we have to discuss this one now. So let's start from the previous. So these are the structure of this is the structure of the sarcomere, which is present on the myofibril area, and this actin and myosin, these two proteins are contractile proteins which are mainly helping on the muscular contraction. On the other hand, we have come to know the structural arrangement of the actin and myosin. But another one protein is also there, which is also helping in the muscular contraction. The name of that protein is the titin. The titin. So what is titin protein? Now the titin protein will help to hold the myosin fibers with the Z-line structure. So this was the Z-line. Right? So actin was traveling towards the center. Right? Now these are the myosin structure. So previously I drawn this picture that the myosin is present on the middle part, but they are not connected with anywhere. Right? But now I am saying that another one protein is there. That protein is known as the titin protein, and this titin protein will help to hold the myosin with the Z line. So this part or this area or this protein is known as the titin. Right? Now we are trying to focus on the structure of actin. So at first of all, the actin filament. So suppose this one is the actin filament, and within this actin filament, actually on the resting condition, these actin filaments are having some specific areas. That means on the actin filament some specific areas are present. So these areas are known as the myosin binding site. So these all the areas are known as the myosin binding sites present on actin. Clear up to this part? So first structural integrity on the actin, that is the myosin binding site. So these myosin binding sites are present on the actin surface, right? Up to this part clear? So this one is the first thing. That is the first thing. Second, this whole structural integrity, that means the actin along with myosin binding sites will be covered with the help of one specific protein. The name of that protein is the tropomyosin. Tropomyosin. So this total filamentous protein or this total protein is known as the tropomyosin. So second one is that is the tropomyosin. Right? On the third, this tropomyosins or another one protein which will again help in the muscular contraction and which is present on the tropomyosin. The name of that protein is the troponin. So those are the troponin, right? So number 3 is that is the troponin. Right? So back to the previous discussion. So when this action potential will travel along the T tubule, so on that moment the DHPR protein or dihydropyridine receptor protein will be sense the arriving of action potential and they will be activated. And after their activation, they will stroke the ryanodine receptor so that the opening of ryanodine receptor will take place, and this ryanodine receptor was present on the surface of the terminal cisternae. And previously we also came to know that these ryanodine receptors are nothing but the calcium ion channels. So when these ryanodine receptors will be opened, so the calcium ion will be released from the stored area, that means from the terminal cisternae. So what is the story from the first again? So origin of the action potential. So origin of action potential. Next one is that is the traveling of action potential. Traveling of action potential. Right? Along the T tubule. Right? So then the voltage will be sensed by DHPR receptor. So one conformational change will take place. Conformational change of DHPR will take place, which leads to the opening of the surface of this terminal cisternae. That leads to the release of calcium ion from the storage area, and this calcium ion will move from this region to the contractile area with the help of calmodulin or calcipostrins. Several calcium binding proteins are there. So with the help of the calcium binding protein, this calcium ion will be traveled from this release site or this storage site to the contractile area where the troponin is present. So the troponin C is there. This troponin C will collect the calcium ion, or in other words we can say that this calcium ion will bind with the troponin C. Up to this part clear? So up to this part, that means up to the release of this calcium ion, this part is known as the EC coupling or the excitation contraction coupling phase. The next phase is the contraction phase. So how this contraction phase will be initiated? This contraction phase will be initiated with the binding of the calcium ion with the troponin C, which I have already told. So at the initiation phase of this contraction phase, the calcium ion will bind with the troponin C. So that leads to the moving or just pulling of the tropomyosin. So when this troponin C and the calcium ion will bind together, that leads to the pulling of the tropomyosin. Pulling of tropomyosin. So what will be happen? If the pulling of tropomyosin will take place, so on that moment, what will be happening? The actin will be exposed along with myosin binding site, right? Because those were the myosin binding sites, and those actin along with those myosin binding sites were covered with the help of the tropomyosin. So the binding of this calcium ion along with the troponin C will help to pull the tropomyosin. So the tropomyosin, when the tropomyosin will be pulled with the help of that binding, so on that moment uncovering of the myosin binding sites will take place, which were present on the actin. So what will be happen? These myosin heads will be attached with the actin. These myosin heads will get attachment with the actin molecules. So all the actin molecules, or the other ways we can say that all the myosin heads will attach with the actin molecule, right? And after that, what ATP synthesis will take place, which is an inbuilt process of the myosin head that leads to the pulling of the actin towards the central area. Pulling of the actin towards the central area, and when this is very important terminology, that is one power stroke will be there. So what do you mean by this power stroke? Now when all these myosin binding sites will be uncovered, so all the myosin head will get attached with the actin molecule, right? And all the myosin head will pull the actin molecule towards the central area together, and that together action of the myosin head will be known as the power stroke, right? So what will be happening? So the pulling of the actin molecules towards the central region, so automatically the distance between the Z line to Z line will be shorter. That means that is known as the contraction of muscle. So after this pulling, or after this central pulling, or that power stroke, central power stroke of the myosin head, when the shortening of the muscle fiber will take place, or the shortening of this Z line will take place, so no more ATP is there, or no more ATPs are available for another one power stroke. So automatically the removing of this energy will lead to the removing of this calcium ion from the troponin C. So what will be happen again? So that again the covering of or recovering of the tropomyosin will take place. So when this tropomyosin will help to recover that actin molecules, suppose this one is the actin molecule and this one is the myosin head, so that when this tropomyosin will recover that actin molecule, so automatically it will just detach, it will help to detach the myosin head, right? So that what will be happen again, the relaxation phenomenon will take place. So relaxation phenomenon will be happen with the help of the restorage of the calcium ion from this contractile zone to the terminal cysternal area. Right? So who will help this restorage of this calcium ion? Now L tubule, on the surface of the L tubule or the longitudinal tubule, there was another one protein structure. The name of that protein structure was SARCA, or sarcoplasmic endoplasmic calcium ATPase pump. This calcium ATPase pump will pump in the calcium from the outer side to the inner side of the longitudinal tubule, and then again distribution of the calcium ion will take place for the storage within the terminal system, right? So that will denote the relaxation of the muscle fibers. So now the gist time. So what do you mean by the molecular mechanism of this muscle contraction? That first of all, when the excitatory type of neurotransmitter will be released from the axonal terminal, it will be utilized by the postsynaptic terminal or postsynaptic area. Here the postsynaptic area will be the sarcolemma, and the origin of the excitatory postsynaptic potential will take place, which leads to the depolarization, right? And depolarization means the formation of one new action potential on that particular area. Now this action potential will travel through the or along with the sarcolemma structure, and there is one anatomical structure of the sarcolemma, that is just one extension of the sarcolemma is there towards the inner side. That extension is known as the T-tubule. So when this action potential will travel along with the T-tubule, again one specific surface protein of one specific protein is present on the surface of the T-tubule, that is known as the DHPR or dihydropyridine receptor protein, which will sense the arriving of the action potential, and one conformational change will take place, which leads to the opening of the ryanodine receptor protein, which is present on the terminal system. So though this ryanodine receptor protein is nothing but a calcium ion channel, so though it has been opened, so the calcium ion will be released from the storage area. Though this terminal cysternal is acting as a storage base for the calcium ion, so though this ryanodine receptor has been opened already, so the calcium ion will be released from the terminal cysternal, and with the association of one calcium binding protein, they will travel from their storage site to the contractile area, where the troponin C is present. Right? So up to this part, that means up to the release part, this phenomenon is known as the excitation contraction coupling phase. So the calcium ion will bind with this troponin C, so that the pulling of tropomyosin will take place. So what will be happened? Now this tropomyosin was helping to cover the myosin binding sites. So though the pulling of tropomyosin is taking place, so the myosin binding heads which are present on the actin those will be uncovered, so that easily the myosin heads will be attached with those myosin binding sites. So what will be happening? Now all the myosin heads will be attached with the myosin binding sites present on the active molecule, right? So they will together pull the actin towards the central area, right, or towards the center, so that the shortening of the sarcomere distance is known as the muscular contraction. So after the complete power stroke, the lack of ATP will take place and another one ATP molecule will bind to the myosin head. And on that duration, what will be happening? This calcium ion will be detached with the troponin C, so that this troponin, calcium ion will just get back to the storage area. So where this sarca or sarcoplasmic endoplasmic calcium ATPase pump is present, and it will help to get back the calcium ion inside the longitudinal tubule area, and then the calcium will be stored again. Thank you.